first thing we'll do is give you a kind of heads up of what we're doing. We're going to just finish off intro to hypothesis today. It's been forever and a day on this section. So what does that look like? Well, section 8. Well, you're going to get a story, and the first thing you're going to do is get setting up what are called the null and alternate. The textbook calls them H0 and H1, but I refuse to call them H1. Call them what they are. This guy here is the null hypothesis. That's its name. In the stories that we're doing right now, it's always going to be mu equals some number. And the guy they're calling H1, which I prefer to call HA, that's called the alternate. So this is just revision. So it's the alternate hypothesis. So there's some story where you want to prove that there's enough evidence that something's bigger than a number, that there's enough evidence that it's less than a number, or there's enough evidence that it's not equal to a number. So let's suppose I wanted to prove that the average age of Scotsmen was more than 35. That's what the alternate would be. The average of the population of Scottish people is greater than 35, and this one would be equal to 35. Once you do that, the second stage of the process is that we collect data. And that will be given to you, but the typical data in no particular order are these four guys. And you need all four of them to do 8-1. So you collect a sample of 100 Scottish guys, and the average is 35.8, and that you're told sigma is 10, and you have this guy called alpha, which is some value. In this case, we call that the significance level. In this case, it's 5%. And alpha is the probability that you do this entire process and you come up with a wrong conclusion. So you end up saying, yeah, I proved that it is bigger than 35, and it was. Then the next step is you get what's called the Z-score, and that is made up using this formula, which is X bar take away mu over that. In this question, 35.8, the mu is 35, sigma is 10, and n is 100. And that ugly calculation there is the Z-score. So I'll just continue this process and see what it looks like. We do a bracket, 35.8, subtract 35, then divide by the square root. In this case, the Z-score that I got, do in red, was roughly, it depends on what accuracy the book wants, but 2.53 to 2 decimal places. Now, stage 3, you calculate the Z-score. You also have to calculate what's called the p-value, and that's essentially the probability that you get a Z-score, in this case, greater than 2.53. Now, the p-value is either a greater than or it's a less than. It can only be one or the other. And there are a couple of ways you can tell. If the alternate has a greater than, this will also be greater than. The other way you can tell is if the Z-score is a positive number, it's going to be greater than as well. Now, this fella we use a calculator feature which basically allows us to get the p-value, and the function is called normal CDF. If you want to know its normal cumulative distribution function. And it has a format that looks something like this. And in this case, if you want it to be bigger than 2.53, you think of it as 2.53 or bigger. And the number 9 is a good placeholder for being bigger. And then you do a calculator one more time. In this case, do that. Second distribution, choice number 2. And it's 2.53, 9, 0, 1. Now, what we want this value to be, or what we're hoping for this value to be, is to be really small. Because the idea that the way hypothesis test works is that we're assuming that this is true, and then we're trying to find out what's the chance that we get an average of 35.8 if this was true. And if that's tiny, then that's telling us that it probably isn't true then. That's probably not right. And therefore the opposite, the alternate, is right. So here we go. And the number I got here is 0.0057. And then the final stage of this process, again to 4, is we do our test. And the test is the p-value less than alpha? Is 0.057 less than this guy? And you're always going to end, oops, I think I had a missing 0 there, I do. Right, it's another 0 there. You're always going to have a choice. It's either yes or no. Right? Would you agree this is definitely less than that, so this is a yes? When your test says that, when you get yes from your test, what that means is there is significant evidence the jargon is to reject the null and accept the alternate. Or in English, there is significant evidence to prove, well, in my story, that the average Scot is older than 35. Now, a lot of work in one of these questions, and we have, I think we've got 4 that we're going to go over. So what I'm going to do now is I'm going to show you the homework questions. We're going to go through this 1, 2, 3, 4 thing, and I'll try and do as much of it on the screen so I don't jump between the paper and the screen so much. So this is my plan. If it doesn't work, that's fine. We'll figure something else to do. Now I've checked this out. You should be looking at a calculator on the left and one of the homework questions on the right.
Yeah.
Looking good? Right, I'm going to turn this way so I can see the screen. So this is a story about dividend yields of banks. So if you're into business, I guess that might interest you. In this particular story, sigma is 3.2%. So these numbers represent percentages. The random bank of 10. The average of all of these is about 5.38. Suppose we want to look at this and we want to see, here's our question. Does this data indicate that the yield of bank stocks is higher than 4.7? And the significance level is this. So all those numbers in step 2 are there. And I will return to it. Right, now let's get the easy one out of the way. That's called the significance level. So 0.01 goes there. Now, there are 4 possible hypothesis tests that we're going to do. In this one, aren't we looking for evidence that it's bigger, higher than 4.7? Now, when you look at it, do you see it's the third one that makes that high? Can you see it's bigger than 4.7? Bigger, higher than 4.7? Use that one. And by the way, it's called a right tail test because it's all the numbers to the right, all the bigger numbers. This here is a pretty standard sentence, and it says, what sampling distribution will we use? Well, if you know that it's normal, which you do, and that sigma is known, which it is, it's that one. Standard normal, assume that it, right? Essentially, it's a normal distribution with known C. You'll never do T distributions. That's for 8.2. You do that one. So you can pretty much choose that answer every single time the question asks. Now, the next bit says compute Z. So I am going to have to take the mean, which is this number, subtract mu, which is this number, and divide it by the square root of sigma divided by, should say 10. So here it goes. Bracket, this is the z-score. And so we're going to take the data, which is 5.38. I'm going to subtract 4.7, the mean. So it's 4.7. Close the brackets. Divided by the square root of sigma, which is 3.2. Divided by n, the sample size, which is 10, close brackets. So when I hit this, I'm going to get the z-score. And the z-score, or z-value as they choose to call it, is 1 point, how much do they want? 2 decimal places. So 1.20. We're comfortable with that? Where that number came from, the 1.20? No questions so far, we're good? Right, now we're going to get the p-value. So, second distribution. Second distribution. Choice number 2, normal CDF. Then I hit enter. Some of you get a little menu, but essentially it's the same stuff. Now I want a 1.2 or bigger. So 1.2 or bigger. And then the mean is 0 and the standard deviation is 1, because that's what's true for a z-score. Close the brackets. And when I hit enter, I'm going to get the p-value. And this p-value is 0.11. Now, they have 4 pictures here for our story, right? And it shows the area corresponding to this p-value. So I'm looking for 0.11 and everything to the right of it. I'm not convinced that number is right. But that's the picture, right? I would have shaded that like over here, but yeah, no. Oh, maybe not. Okay. Yeah, it makes more sense. It is to the right. I'm thinking that is the z-score, but the z-score we had was 1.2. Well, it's still not quite right, but it's the picture. Can't argue with that. Now, we have a 0.11. Is that p-value 0.11? Is it less than the significance level 0.01? So is 0.11 less than that? No, right? It's not less. So we go through this and we choose, what does that mean? At the 0.1 level, we reject it, we fail to reject it, that one. You fail to reject it, and it's not statistically significant. Now, if this guy here had been tiny, then we would have accepted it, right? It would have been statistically significant, and we would have picked that one. And there's no situation in the world where I would pick the middle two, because they don't make sense. Now, in English then, since we didn't find anything statistically significant, we choose that answer. There is insufficient evidence at the 0.01 level to conclude that the average stocks are higher. And that all hinged on the value of this fella, the p-value. It needed to be significantly small for us to be able to say anything useful. 0.11, nothing particularly interesting about that number. Are we good with that question? Any questions about it?
I had one question for
Yes.
I think this one, I started to do it, and
Number 9 or 10, this one that we're looking at?
oh, I think the one before it.
Right, so the one we just finished, this one. Gotcha.
Yeah, and they had me when I was getting like the Z score, because they had like I looked it up and they had like this video that you could watch on it.
Right.
And they had me use like a different formula, like where it was x bar minus mu over sigma over the square root of n instead of the square root of sigma over n.
Oh, God, yes. That was just me being careless. That is the right answer.
Oh, okay. Okay. Got it. Because that's what it had me do, so I did it. But
yeah. I was just.
And that threw me off for a while too, because I was getting the wrong answer till I shoved the root down into the bottom.
Yeah. Somewhere or other, I just got old. What can I say? But I will make sure I do the sigma over root n. I think it's easy to say that. Sigma over root n and root and sigma over n. It's vaguely easy to do. Okay, so let's do question 10 then. We've got a whole load of data. It's about a horse. This poor little horse has had its, the vet has taken some blood samples from it and they're looking at its glucose levels. And thankfully they've told me the average is 93.3. They've told me what sigma is, and they've told me significance level, and we're being asked, is there overall level, is there evidence to prove that the overall level is bigger than 85? So let's do one thing at a time. Significance level, get that out of the way. Okay. Oh, by the way, that other question in the beginning was perfectly fine. All the answers were right. It's just the score went wrong. Okay, in this story, the average level greater than 85. 1, 2, 3, 4 dots. Which one is the right null and alternate for the average glucose level higher than 85?
First one.
Last one. Okay. Yes, last one. And this fella here, just pick the 4th dot. Right, now, compute the Z value for this one correctly. Brackets. X bar, which is 93.3. Subtract 85. Close the brackets. Divided by, I'll put a little bracket just to be safe, sigma, which is 12.5, divided by 2, 4, 6, 8. And nobody noticed, it's a square root. I caught myself in time. I think that's enough brackets. Looks good. So 1.87, does it round up? Yeah, 1.88. Let's get the p-value then. Second distribution, choice 2. I want a 1.88 or bigger, and the 0 and 1 are fixed, they don't change. And the p-value I get is 0.03. Now, is this guy 1.88? Oh, can you see that picture now matches exactly where 1.8 is? You know, this funny writing, but I guess can't avoid that. Yeah, can I put it from this side, right? Number 1. Now, the test is coming up. Is this number, our p-value, less than 0.05? So is this less than 0.05? Yeah, it is. And that means it's statistically significant. So we have 4 choices, but only 2 of them are statistically significant. And when it's statistically significant, you got that guy. Now, what does that mean? It means we have evidence to show that this horse's glucose is, in fact, like we thought it was, bigger than 85. Went smooth? Smoother. And just quick scan through. Oh, we've got 4 to go. Okay, so I'm going to have to skip one. One will I skip? Don't like that one. Skip that one. Okay, this is question 13. And in question 13, there's 2, 4, 6, 8, 10, 12, 14, 16 data points, which is verified there. And we are looking for evidence that it's different from 11%. Right, so different. So it could be bigger, it could be less. We're just trying to find evidence that it's not 11%. Now the significance level, pretty standard. Now, if it's not equal, right? Different means it's not the same as. Do you see that we pick the top dot? Right, not equal, top dot. Two-tailed. So if I go back here, can you see the two-tailed one is that picture? I know it's going to be that before I even do it. Right, returning to the question, isn't this a standard answer that's true for all of them? So you pick that one. Now, Z-score coming up. Bracket. X bar, 12.6. Subtract. Where are you, sigma? You're in here somewhere. 11. Divided by, do a bracket. Sigma, which is 5, divided by the square root of n. And the square root of n is the square root of, how many data points? 16. Oh, that would have been 4. And I'm looking at 1.28. Good. Now, finding the p-value. Second distribution, choice number 2. We have to be either bigger or less. That's the only choices we've got. In this case, since it's a positive number, I'm going to look for bigger than 1.28, comma 0, comma 1. And now I'm going to hit that number. Agreed? Now, when it's a two-tailed test, right, that's a not equal to situation, you have to adjust the test. Remember, the test is the p-value less than alpha, right?
Mm-hmm.
When it's a two-tailed test, depends on what textbook you read. One of them says, for a two-tailed test, you check, is 2 times the p-value less than alpha? Or equivalent, is the p-value less than alpha over 2, right? So you can choose to either double the p or half the alpha. It has the same effect. In this case, is 20% less than 10%? No, it's not. So that means it's not statistically significant and that there is insufficient evidence. So the tweak that you'll need to make when it's a two-tailed test is, instead of is the p-value less than alpha, check is 2 times the p-value less than alpha. And you might say, well, why did they double it? Well, seeing a two-tailed test, couldn't you have numbers at the big end and numbers at the small end? So the doubling kind of compensates for that. Right, 2 more questions to go here. Anything you want me to go over? Any questions? Are we good?
I had a question.
Yes.
So when I'm putting the normal CDF in the calculator, there's a screen that pulls up and it says lower, negative.
Right, so how do you do that? Let me show you what it might look like and show you how you cope with it, right? So I'm going to leave this page for a second, right? And we'll have a look at, because some of you, you've got a modern calculator, that's all it means. So when you do the normal CDF, this is what my normal CDF would look like. I actually type in the numbers, right? So I typed in 1.28, comma 9, comma 0, comma 1, right? Now, what you have is, I think it's, you said it says lower.
Yes.
Then it says upper. And then some like mu and sigma, what does it say here?
And then paste.
Oh, it just has paste?
Well, it says both of those still, and then it has paste at the bottom.
So does it say mu equals 0 and sigma equals 1? Does it have that in
Yeah,
it?
it has that as well.
Okay, so you have a lower, you have an upper. Does it just say mu and it has a 0 in there and it has a sigma and it has a 1 in there? Is that the kind of way it looks?
Yeah, and then it says paste at the end. Yeah.
And then it says paste. Okay. 1.28 is your low guy. 9 is your big guy. Leave that 0, leave that 1. When it highlights paste, hit enter. And that will appear with the answer, I hope. Or that will appear if you hit enter again, the answer. You want to try that and see what happens. So 1.28, then hit 9. I guess if you just hit enter and enter, it'll get you by these two. And then hit enter when it's on paste. Did this appear or did this appear on the answer?
In the paste, it had like some like negative 99 something. So I just deleted that. So I'm going to put 1.28.
Right, so when you did your paste thing, I'm trying to kind of do something. Is this what you saw when you were finished? Because that'll tell me everything's fine.
Oh, okay. Yeah, 0.002726.
Well, I got points.
Or I mean,
100.
yeah, 0.100272.
Then you now know how to make it happen. So you keep doing that. The key is just to tell it these two numbers. I think it looks like the rest I've just hit enter until you can't hit enter anymore. Okay. Does some of the others, do they have that same calculator, the more modern version, where they give you a little screen menu rather than you have to type it in the way I have to do it?
Okay.
Okay. Let's return to our second, I think it's our second last one. So, here goes. Okay. If you're in the medical field, you may know this. I didn't. That the total blood volume per body weight in kilograms is an important thing in medical research. Healthy adults tend to have a particular number, around about 28. So if your total blood volume per kilogram is 28 or thereabouts, you're probably pretty healthy, right? Nothing, at least as far as your blood's concerned, is out. However, if it's too low or too high, so if it's bigger than 28, that's too high. If it's less than 28, it's too low. That very often indicates some type of illness, and the doctor should maybe look into it. So this poor guy, I think his name's Roger, had 7 blood tests, and these are the values that he got. And so right off the bat, we have to do something in this question we didn't need to do in any of the others. And that is, we have to find X bar, because they never told us it. And I can do that. And it's small enough for me just to do it as a calculation. So just do a bracket and add up, because there's not that many of them. Right, that's them all added up, and I'm now going to divide it by, is it 7? 1, 2, 3, 4, 5, 6, 7, divided by 7. And so, oh, okay. Kind of surprised it was such a nice number. Now, if I read on a little bit, this data is his blood cell volume. Assume that it's normal. There's the sigma. Does this indicate that it is another different, right? So different, right? Not the same as 28, and not the same as, in this case, is the fourth one, agreed? That guy. And the standard answer for that one. Now, computing the Z value. So I'll do a bracket. 33, take away 28, divided by, put a bracket in, and sigma's here somewhere. Oh, there it is, 4.75, divided by the square root of 7. And I end up with a 2.78. Why do I know, well, I guess 792 decimal places. Why do I know that I'm probably going to get a significant result here? Well, what's special about 2.75 Z-score that tends to mean you're probably most of the time going to get a significant result? Phrase it a different way. What are the typical range of Z-score numbers? -3 to +3, right? In fact, if you're bigger than that, aren't you an outlier? That's how unusual you are. So if you get a Z-score that's 3 or bigger, then I will guarantee you'll get a significant result. But if you get a number that's pretty darn close to 3, you've got a very good chance that it's going to be significant. If you get a Z-score of 1.2, forget it. It ain't going to happen, right? Pretty sure of that. So let's get our p-value. We do second distribution, choice 2. And since this is positive yet again, bigger than that number, 0 and 1. Enter. So we are looking at a p-value of 0.0026 to 4 decimal places. Now, we're going to tell if it's statistically significant. Now, it's a 0.01 level. If you double that number, is it still less than 0.01? So if you double that p-value, is it still less than 0.01? I see some nods, so I'm saying I agree. And so that means it's statistically significant. And when it's statistically significant, you reject the null, and that's good. And the answer is that one. As we keep going through these questions, because I only really have one last one I want to do after this, do you get the flow of how these questions work? Because they changed the story at the beginning, but after that, it's kind of same old, same old. So, where is going to be my last one? We've done the blood one. Okay, there it is. Make it this one here then. In this story, nationally, about 11% of the wheat crop in America is destroyed each year by hail. So I guess what farmers do is they take out an insurance policy against their crops being destroyed by lightning, tornadoes, and everything else, including hail. And an insurance company is studying what kind of damage was done in one county in Colorado, and these are the claims. One person said 17% of his crop was destroyed, and the other said 5%. I'm already kind of suspicious. You know, if it's a hailstorm and you've got a big field of hay, would you probably expect most of those numbers to be pretty close to each other? And, you know, I guess you could have a localized hailstorm that only hits 2 farms, but in most cases, I would think it would be bigger than that. So I'm a bit suspicious, and perhaps so is the insurance company. And the question there is asking here is it different? Oh, we get another different again. So is it different than typical? Right, well, did I do this one? I've got all the numbers. I've done that one. Okay, we are going to finish with one of mine then. I wouldn't have the numbers there if I'd done it. So, okay, since it's going to be a fun one, I need a story. So, how about we'll do it in blue. I'm going to. I thought I'd mute everybody, but evidently I've not. Now I've muted you. I'm going to make up a story about Scottish people because I feel like it. Right. Is there evidence to show that more than 20% of adults in Scotland get drunk? At least once per week. And can I tell you right now that it's actually a lot bigger than that in Scotland. It's quite different culture from America in that respect. Right, so is there enough evidence to show that 20% or more get drunk? So that's the story. So we collected a sample of 500 Scots guys, right, males and females, adults. And out of that lot, 23% said they had got drunk last week, right? 23%. sigma is 10. Right, what kind of significance level do you want for this story? That's typically given. But what do you want it to be in this story? Somebody give me a number and I'll use it. I'm getting old here. Can you not see the grey hairs?
5%.
5%. That was not a trick question, by the way, right? That was just me getting student participation, right? Getting you to answer some things, getting you to take part. Right. So pretty much everything we need to know is here. Agreed? So H naught and HA. So more than 20%. So greater than 20. And that is always equal to, right? So equal to 20. You agree? Z score. It is 23 take away 20, 10 divided by the square root of 500. On my calculator then, do a bracket and do 23 take away 20, close the brackets, divide 10 divided by square root of 500. And I am looking for a Z score of 6.7. Do you know a Z score is 6.7 is like you could win the lottery easier. That's how rare an event that is. So we are going to do a p-value that is going to be ridiculously small. And let's find out what it is then. It's the probability that we get a Z score greater than 6.7. So it's going to be 6.7 or bigger. So that looks like normal CDF, choice number 2. And it's going to be 6.7, 9, 0, and 1. And this number is basically tiny. Right. If I rewrite that the way you would probably want to see it, say in a chemistry class or a physics class, isn't that scientific notation? That's what this is. And that means, the way I look at that, that means 11 zeros, including this one. So 1 decimal point, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you fill in with the other digits. Was my prediction about how tiny that p-value came out, right? It is extremely tiny. It shouldn't take much then to do this then. Is the p-value less than alpha? Oh, by the way, if you round this number off to 2 decimal places, isn't the answer essentially 0? So is the p-value less than this fella? And the answer is yes. And then don't you choose the dot that says significant, reject H naught? And then don't you choose the dot that says statistically significant? So far, so good? Now, although that is the last question, there are a couple of kind of loose ends I want to get started with. Maybe it's just bad luck in the questions I've chosen, but I haven't really given you many situations where you're going to go the other way around. So I want you to imagine a question where we got a negative z-score, because that can happen. Now, to get the p-value when it's a negative, you're going to find the probability, right, that z is less than that number. And that's where you have to do a little change to the numbers that go in the normal CDF. The 0 and the 1 are never going to change. But if you want something less, right, a negative number here, you go -9 . Now I'm going to do above that a positive version of the same decimal. In the case where you get a positive z-score, you are looking for greater than a positive number. And that's going to become this normal CDF. In fact, isn't that one the situation that we've been coming across today? The one where everybody was positive. So we've done tons of them, and we haven't seen this happen much, but you know this can happen as well. Now, you will get a decimal in both cases. It won't be, oh, that's going to be a negative number. It won't be. It'll be a decimal. And if it's small enough, it'll be significant. And if it's not a small enough p-value, it won't be significant. And that's the same truth as in both cases. So when you do your test is still going to be, is the p-value less than, you know, whatever alpha is. Okay, do we have any more questions?